Okay. Hello. So, my talk today is about how to. Are we good?
I got the different talking here. How to hack the bug bounties.
Yeah, that's it. I kind of retitled it. So.
What you said? The title card. But welcome to the club.
Yes.
Okay.
So, the title of the talk obviously is two different titles, but this one is ABM, Automated Bounty Machine, Automated Ownage of the Human Factor in InfoSec and bug bounties. So, this covers a whole different swath of technologies. When I first started thinking about what I wanted to do with this project, it was about 4 years ago. Just before Shodan came out with their MongoDB report, which it promoted on the page, it had like 36,000 plus hosts that had open Mongo instances, and across the net. Prior to that, I had just started doing some full net scanning as well, looking for exactly that. I had come across Mongo in a work project and noticed that our admins had deployed into production several instances that were bound to 0000 with no auth. So, luckily ours wasn't found before I was able to fix them, but it got me thinking about what I can do. I was looking to get into bounty hunting, and this sort of was my prompt to do it. So, who am I, though? Mike Baker. That's my name. I'm Bike Maker on Twitter. If you know me, Pipe on various IRC networks. I founded and am lead researcher for a company called BAFSAC LLC, based in Ann Arbor, Michigan. InfoSec consulting and research company. I contribute to the AppSec team at Arbor Networks as well. That's my day job. I work physical security at DerbyCon, a couple other cons occasionally as well. So you might see me walk around with a red shirt sometimes, depending on where you are. And then the last item, that being a bug bounty hunter, as a result of all this that we're going to talk about. So when I decided I was going to do this, I wanted to figure out what the path of least resistance would be for me to enter into the bug bounty game. Because at that point, there weren't a lot of large names in the bug bounty bug bounty game on the corporate side. There were some that had joined and started offering programs, but there wasn't as many as there are today. So, did a little bit of research. A company named Baker Hostetler. They're a pretty large consulting firm. They put out this handy report that covered all of their incidents that they worked for customers over the course of the year 2015. And so you can see the breakdown here, but essentially what it came down to is that around 30% of all of the incidents, 300 plus that they had worked on for various customers, were in some way, shape, or form attributable to humans. Usually in a scenario where it was a misconfiguration that was not checked or just left at default when the package was installed and then pushed out to production. As I just talked about, I mean, I experience this pretty regularly, auditing things in my 9 to 5. And if you guys are in InfoSec currently, I'm sure you've probably seen the same.
I have to interrupt you with Jacob Cartwright. If he's here, they want him at the front desk. Jacob Cartwright.
Okay.
Thank you.
Sure, no problem. Jacob Cartwright, if you're here. I guess they want you at the front desk. So, doesn't look like it. Yep. Right. So we see misconfigurations and human attributable errors on the regular. So that kind of pushed me down the path of how I wanted to go about this a little bit further than just thinking about Mongo. Right, so having found this, I believe that I found my path of least resistance, right? What was something that was going to be low cost of entry for me into the bug bounty game? What was least utilized by other people that were working bug bounties as well. So there's a lot of people fuzzing apps at that point, and protocols, and a large majority of the companies that had bounties, the submissions were things like fuzzing results, and then automated scans, SQL map, things like that against just web services and things of that nature, which isn't a bad route to go. You find a lot of good things that way. But I didn't want to just become part of the static noise already that was present in the bounty side of things. So I set a few requirements for myself. Basically, again, little or no manual effort once I got it working and rolling. I wanted to be able to choose specific services and or vectors to target here. So what I came across, again, MongoDB was huge at that time, so that was the first thing I added to my services list that I was going to look at. There's a lot of NoSQL technologies out there that are all similar in nature. They don't necessarily get deployed by default with security in mind, I guess. More ease of use, I think, is how they're designed. So I wanted to take advantage of that. Nobody seems to read the manuals either before they deploy it, or even after they deploy it, usually, unless they hit a problem, right? So I wanted to use that to my advantage. So what did that result in? Project that I call HEAP, Human Error Autoponage. So I built the back end of this first, and I basically wrote a Python daemon that served to basically a Python daemon supported by modules that you could add on the fly for various different services. Right. So supported by MySQL server for results and for target storage on the back end as well, target and result storage. And then the front end came a little bit later, but it's just a friendlier interface to actually add new hosts. So basically, you go to the web page, the control panel for this. You can enter hostname CIDR, a single host CIDR block, or a domain, whatever you want to do. The company name, any notes that you personally want to add, and then the notify email address. So the way that this application actually works is, again, it checks our module storage, and for any new host that you enter, it enumerates each host in a CIDR if you do the CIDR. But for any new host that drops into the targets storage table in the database, it looks at, hey, what modules do I have available? Okay, cool. I've got Mongo, CouchDB, Apache OpenIndex, Google Dorking enabled, and says, okay, I'm going to start firing it off at these hosts. If it finds any results, it sends a notification email to whatever address you configured in that front end and that UI. And so in the notification email, you get things like the host that it was found on, what was actually found. If it's a Mongo instance or any sort of database server instance, it gives you a listing of all of the tables or collections that's discovered. It'll replicate all of that data back locally as well to a storage device, and then it gives you the path of where that's stored on the storage server. So what that does is it allows me to quickly and easily verify, hey, yeah, I found something cool, I found something new in this new target block. I know exactly where it is. I can go look at it, verify whether or not the data is critical. On my to-do is to add automatic verification of data, searching for PII patterns, things that you do similar in HIPAA engagements and audits and things like that. But that's not done yet. So hopefully soon. So the technologies and servers that this will find and pull data back from today. Again, basically no SQL instances. So we've got Mongo, there's CouchDB, there's a number of different ones, right? Any open Redis servers running, it'll log in, dump, and capture any entries in the Redis instances. That one's a little more tricky to know what you're dealing with, though. If any of you guys have worked with Redis, the data isn't necessarily easily identified once you're able to actually look at that data, unless you know already what is utilizing that data on the front end. So that one does require a bit more manual effort, unfortunately, if it does find some. And then, yeah, the Google Dorks for Open Apache directories. That one is surprisingly successful, even using IP addresses. A good example of this is, a good example of Open Apache instances paying off for me that this project has found is AT&T. So I did a quick search on Google looking for companies that ran their own bug bounties instead of going through something like HackerOne. I've found, at least personally, that I get a better response time from companies, as well as potentially larger bounties, comparing similar reports in the HackerOne type setups and direct submissions to companies. I've gotten considerably larger going directly to the companies. So AT&T, I started looking at their address space, their corporate side of their public address space. And I got a report email alert from Heap saying, hey, I found this open Apache instance directory listing on this server 209. Blah, blah, blah. And it gave me a listing, and it looked like a bunch of cert files in there. So I'm like, oh, okay, I'll go take a look at it. Went to my storage server and looked at it, and what it was the entirety of their SSL key infrastructure info. So it had all of their public and private keys that were unencrypted for all of their SSL infrastructure. It had their code signing keys. It had anything that you could possibly hope to find as an attacker was there. So I submitted that with AT&T. They were very happy about that. I submitted similar through, like I said, HackerOne type bounty programs, and the payout that I got from AT&T versus a comparable sized organization I went through one of those was about 3 to 4 times larger. So just as a specific example there. So now the fun part of the talk. I'm going to go through some of my actual findings with you guys. The most notable is up in the top left. This is what I thought at the time was just a random Bitcoin server, database, storage system, whatever. This was originally in a Ali Cloud, which is Alibaba's sort of EC2 AWS competitor, mostly in European side of the globe, though. But I logged into it, took a look at, or I logged into the storage system, started looking at the data that it pulled back, and what I found was there were, again, Bitcoin addresses, millions and millions of Bitcoin addresses, and there were the private keys for millions and millions of Bitcoin addresses that were not encrypted, again. So it's like, oh, okay, this is very interesting, right? I don't know if it's somebody that's just trying to do some sort of address space attack on the Bitcoin infrastructure, or what it was at that point. So I wrote a small Python script to query. I run a full node myself on a different server, so I started querying my transactions table in my full nodes database, and I started getting addresses back from the ones that I pulled from this server that were in the hundreds and thousands of Bitcoins that could be mine at that point, effectively, if I was not a good person. The total Bitcoin haul on this was, let's see, it was 241,559 with .32 and some change left over. So that's over 230,000 Bitcoins that I could have just like walked away with. Yeah. Yep. Yes. It came out to about 104 million at the time of actually doing the search in US dollars. Yes. So I'm like, okay, I've got 2 kids, got a wife. I could potentially buy a small island and just live comfortably, right? I could, there's so many options. But I decided instead of doing that, since my hat is no longer black, I would try to track down and figure out what company that this data is attributable to. Because one problem that I need to try to figure out how to work out with the project right now is if I'm scanning cloud address spaces, if I find results, awesome. Sometimes I can easily determine what company those results belong to simply by looking at the data that's there. But in some cases, like in this one, it wasn't immediately clear what company, what exchange, which it was clear as an exchange at that point, what exchange that those addresses and things belong to. So it took a little bit of digging and investigation. I was able to track down doing some, basically some forensic tracking of Bitcoin transactions back to a particularly large Chinese Bitcoin exchange. They started out in China. I think they've expanded to the US at this point. And reported it to them. They were quite pleased and happy that I did that. Because that was $104 million of their customers' money, right? And customers' Bitcoins. I wound up getting a bounty out of them. They don't have a formal bounty program, or they didn't at the time. But their gratitude for not running off with their 231,000 Bitcoins was to give me 25 of them. So that wasn't too bad at the time. Not too bad of a reward, I thought. That one is the best story of my results, but so on the right here, Newstar. I came across in EC2 an instance that looked immediately to me like it was going to belong to Newstar. You can see from some of the listings of the collections here, things like SDB. There's a couple of them that I cut off on the bottom here that had some identifying info in the actual collection name, but it made it clear that it was data belonged to Newstar. What was good and interesting about this data is the admin collection up there, and the diagnostics and the private collections. So those tables contain things like usernames and passwords for all of their employees for their cloud infrastructure and their DNS infrastructure. Private keys, again, unencrypted, no passphrase required. Private keys for all of their employees that had access to their cloud infrastructure. All of their SSL keys again, and of course their private keys. No passwords required. So yeah, that was another company I was pretty happy to get a report from me on that. Got a decent bounty from them as well. Again, I think they still don't have a formal bounty program, but what I've found is if you come across something critical enough and you report it to the company and are responsible about it, usually they're more than happy to compensate you for your time and effort in giving them the info and not trying to sell it. Right. So at the bottom, 48 gigabytes worth of SIM cards and SIM information related to a Mexican oil company from their remote mining or remote oil extraction rigs. They had connecting back to the cellular network, so it could have cloned any of those phones at that point, right? It had all the ISMI info and things related to the phones that they were connected to, or the phones and or the modems they were using. Google, I didn't put anything up here, but let's see if I can show you right now. But so Google, this was another very, very large bounty for me here. That again he found and got for me. So I started scanning Google's cloud offering address space, right? It's in the 8.4 something range, 8.41, I believe. And I came across several hundred open Mongo instances, but almost probably I'd estimate about 90% of them were customer, like just random, personal hosting customers that had spun up instances and were hosting blogs and things like that, storing data in them. Nothing was useful in those, but in this one particular IP that I came across, the whois info for it, the org was listed as Google Corp, whereas in all of the rest of the IPs it was listed as Google services. And so anything listed as Google Corp in their whois info, or in the whois info, indicates that it's internally utilized by Google for something. So looking at the data that was pulled back by Heap on this, what I found was it was actually data that was stored in a control panel that they had for their demo Google Search Appliance device that they used to show to potential customers that want to buy a Google Search Appliance. The interesting thing about this for me was it had stored a user at google.com authentication information in the Mongo instance. It also had separate admin credentials for the GSA appliance. So I was able to pivot off of that information and get into the Google Search Appliance. They don't have shells enabled by default, but I was able to download the configs. And I found a couple of other exploits within the actual Search Appliance interfaces web interface itself as well, which allowed me to basically pop a shell in the box and exploit the login page. I dropped a flash ODE on there, and then reported it to them as a bug bounty submission. So once I was in the system, they had demoed this box to customers that were defense industry customers, large financial firms, and there was still sample data that they had actually pulled in from those customers to demonstrate the functionality of the product. So they hadn't been purging the data between demos, which is problem number one. Problem number two, they're storing all of the credentials for it in the Open Mongo instance. Problem number three, there's exploits actually found in the code of the product itself. With Google, if you can combine multiple vulnerabilities, they love you, and you get a multiplier on your bounty award. So this was a hefty reward as well. So again, little manual effort. I mean, it took me about 30 minutes to find all the Google-related stuff, and it paid off with what would normally be about 2 months worth of my salary. So. This point of sale log from some random Arby's they had storing in a Mongo instance in EC2 for some reason. I just thought that was funny. Like, why would some random Arby's be storing their point of sale config and sales transaction info in an instance? It just didn't make sense. So those are some of the more notable Mongo findings. Some of the other good things that I found was NASA JPL. Right? So they had an open FTP server. This particular subnet of theirs shouldn't have been even able to get to the internet, but this one was. First thought, honeypot, right? You have a host within a subnet that shouldn't be able to get outside, is showing that there's a host open with an open FTP server. It's got to be a honeypot, right? So I basically logged into the FTP server, started looking through, and it became pretty clear right away that it wasn't a honeypot. There was actual transactions and things happening on the system real time with what looked to be real credentials. Thankfully, I have a contact within particular government security side of things. Was able to report it to them. It was legitimate. On that system, so we were able to pull down. What were we able to pull down? So the FTP server had the root directory. It's in a Windows system set to /. So when you do that, you get basically the My Computer access to it, right? So you can go to any of the drives that are mounted on the system, and you can start exploring them. So we're able to get to one of their NAS systems pivoted off of that FTP server because it was mounted to that FTP server. And in the NAS system, we were able to pull down copies of backups from various desktop devices within NASA JPL's office, well, one of the offices anyway. And within those backups, it had all of their SAM credentials, so we were able to crack those. And then we had basically, about 100 employees worth of data. That was reported and fixed. Thankfully, it's no longer showing up. But they were also pretty happy about that. All right, here's actually the Google data that I was talking about a little bit ago. Seeing the user collection there at the top. Their password. That's just a shoddily encoded string. Right, so GSA collection is where I figured out, hey, this is actually pointing to some Google search appliance for some reason. And that is apparently a password that they reused at the time across their corporate LAN as well. So one other thing I forgot to mention is on this Google search appliance, once I was able to access a shell, it was dual home. They had two NICs in it. One was facing the internet, one was connected to their LAN. So I didn't pivot into their LAN, but could have easily, very easily, based on that password being reused everywhere. So don't do those sorts of things, people. Right, so to give you some numbers, right? So far this year, I've pulled in about $75,000 in an automated fashion, which has taken me probably a grand total of about an hour and a half worth of actual effort.
Started with that?
I got to get you to hang in for the payoff. Right. So the actual time commitment was, under 10 hours for that amount of money for me, of manual effort, which I thought, thinking back to my requirements that I set out for myself at the start, is far exceeding any expectation I had of actually what I would wind up doing. So that's satisfying. What I also kind of figured out is that this utility sort of fills a need or a gap that you don't find covered in any other sort of security scanning products. So Nmap, obviously, if you're Nmapping, you're going to find these sorts of misconfigurations and things like that, but it's not immediately clear whether or not something's misconfigured from that, right? You can run the Nmap scripts, and it'll tell you if something, anonymous access for FTPs, for example. There's Mongo auth modules as well. But nothing that was going to fill this sort of need for me to actually start pulling data back, give me contact info for the company in question, allow me to specify multiple targets at any given time, and report on those targets individually in an easy to identify manner. That also alerts me proactively if it finds something. So I can fire this off at /8 and for in EC2, for example, and then go play hockey or something, and then when I'm done, change in the locker room, look at my phone, and I've got 50, 60, 70 email alerts from Heap saying, hey, found all these instances, and start scrolling through and looking for interesting names, interesting collection names in the Mongo instances, or interesting file names if it's an open indexed directory. It's just easily digested. It's easily utilized and easily actionable intel from the project that makes it really simple to know when something's there. What I've also added recently is a point-in-time mapping for a given address space. So once I add, say, 8.000 to the project, it builds an understanding of what's running in that space over however long it takes to finish. And then periodically, which is a configurable interval time frame, it'll go back and start re-looking through some of that space randomly to make it easier to get through everything. And update its understanding of what's running in that space. So to me, as a corporate security guy in my 9 to 5, that's useful information. If I'm a company that heavily utilizes EC2, for example, I can say, okay, what's our address space within EC2? Okay, it's a /16 or /22 or whatever you have configured. I can put that in this project and say, okay, go look and see if there's anything open, anything that shouldn't be there, any open Apache index directories, whatever might be there. It builds that. It lets me know a baseline of where we're at right now. If anything new comes in, again, you get an alert. If it's still the same open instances that it's already found, you don't get alerts for that. Again, you get the one initial and that's it. So I'm trying to build a front end to that part of it to make it a little bit easier to kind of go back and forth in time and see what things look like. But the idea there is that it gives you something as a security professional in a company to easily use for judging what your stance is as a company, right? You can say, okay, we started at this point. We had all of this open stuff. None of our firewall configs were correct. We had open access all over the place, and we're down now. Here's what we're actually showing that we have, 50% less, or whatever the case might be, over time as that continues to improve. That's something that's easily conveyed to these C types up the chain. That is the type of information they like to see, right? Just makes your job easier as an InfoSec person. So there's nothing out there that did that for me, right? There's nothing out there that I could find that would do that. Looking for that human error element, right? And capitalizing on it. So, yeah. So I mean that's pretty much the gist of what the project is, what it's done, what it does for me. A little bit of time left, a little bit more time than I had planned on. So, if you guys have any questions, I'm happy to answer for you. Sure.
So, how concerned are you for? You've done some research against folks that didn't have official bug bounty programs. How concerned are you about attack vectors and communications and stuff like that?
That was initially a big concern. Weave, for example, is a good example of what can happen, right? But so when I first started scanning, like once I had the product in a workable state and I started actually finding targets to plug into it, I strictly focused on companies that I knew had active bounty programs, so AT&T, Google, et cetera, et cetera. And I stuck to that for probably the first year and some change. And so what that provided me was, I think, a little bit of, I guess, I don't want to say reputation, but a little bit of, almost, equivalent to like a case law example, right? Like, hey, I can go to another company and say, hey, look, I'm this security researcher from this company. I found all these other things for these other companies. I'm legit, I'm not trying to steal your stuff. I just wanted you to know and disclose this information responsibly, that you have this data that's in the open. And I've not come across a company yet, even expanding and now basically scanning all of EC2's infrastructure, all cloud providers' infrastructure. I've not come across a company that hasn't been extremely accommodating and basically happy for the submission. Not all companies are as willing to compensate for time and effort, but I don't really care about that because it doesn't take me a whole lot of time and effort, right? I'm just exactly. So I basically just want to try to. The goal initially was I wanted to get some bug bounties, but I also wanted to increase education across the companies where I found this information from, right? So that they know not to just apt install, MongoDB server and, service start Mongo and think that they're okay, right? Wanted them to understand, hey, this is what it does. Here's your data. Don't do this anymore. They could use that as an example going forward, right? And I think I've made a pretty good dent in that over the past 3 or 4 years. I don't often find that once I've reported something for a specific company that I find any further instances for them. It happens occasionally, but it's rare. So I guess the short answer to that is I'm not too worried at this point. And I've not really had any result like that.
Negotiate it all with folks about what the payment should be?
Yeah, absolutely. Unless they have an established program, right? If they have payment guidelines, I'm happy to fall in those payment guidelines wherever it might. If they don't, and they seem willing, yeah, I'll absolutely negotiate with them, especially depending on the type of data, right? So there was a one Mongo instance I found that was immigration information. So I don't know. I didn't know if it was like a government system, right? Like ICE sort of system, but it was passport numbers, it was driver's license numbers, it was names, dates of birth, last entry date, destination country, like all of this PII for people, and so it wound up being a private company that housed that information. It was a travel agent, actually. And so they had no bounty program, but they're like, hey, what can we give you for reporting this to us? Because they hadn't detected any compromise or any data being exfiltrated. It doesn't mean it didn't happen, because obviously I grabbed a bit of it as well. But they were more than willing to compensate. And so, I basically gave them a quote that was something like, figuring out what a similar company of their size and roughly industry had paid in the past for something similar, and then adding like 10 or 15,000 to it and seeing what they counter with. So that tends to work out. Any other questions? Sure.
Any advice for like people trying to get into this and legitimize yourself if they're looking like somebody that's trying to hold a ransom?
Absolutely. That is something that you have to be very careful of. Right. So I think the best approach to that is taking the same approach that I took at the start, right? Stick to companies that have bounty programs. Because what that does is it provides a paper trail for you to reference, saying, hey, look, I am a legitimate researcher. I've reported to all of these other companies. And just be explicit when you contact the company in question, right? Let them know you're not trying to, I'm not holding this information ransom for you. I want to just report this to you so that you're aware and you can fix it. Because when you come with that sort of approach, although it may ultimately lead to you getting some sort of money from them as a thank you, if you lead with saying, hey, I just want you to be aware, I want to help you fix this, they tend to be a little bit more friendly, because they think, they get that feeling, that happy feeling like, hey, this guy could have, tried to blackmail us or whatever with this info, but he didn't. So,
what factor do you usually find yourself going through first if it's a newer company or trying to research? Do you recon the company and then go through the IT department, try to go through administration?
A little bit of recon, but I'll usually go Twitter first. If they have a Twitter handle, I'll ping them and say, hey, do you have a security person I could contact? So if you check out my Twitter feed, I think leading up to this conference, I was doing some new scanning to try to get some more recent examples than I had previously, and I pinged like probably 20 or 25 companies in the past 2 weeks. I got a response from probably about half of those within the last 2 weeks. Usually they're pretty slow response that way, but you do inevitably get a response. If you word it like, hey, I've got a critical thing to report to you. Can I have somebody to contact, please? So,
do you find companies that build a bug bounty program because you've done that, or they don't even have a method to pay you?
Yeah, I've not found not that I don't know of any company that has actually built or joined a bounty program as a result of me reporting to them specifically. That doesn't mean it hasn't happened. I just don't know of any. Slow payment on an agree to award, that does happen, but yeah, I mean, it's not, even in the legitimate programs like Google, for example, there's a whole heap of hula hoops you have to jump through to be able to get paid. And it takes, usually about a month plus from the time that they say, hey, we're going to give you money for this, to get the actual money for it. So I would say don't rely on this for a source of income as your base source of income until you start getting a consistent roll-in of reports. So, any other questions? No?
So you get the report prior to the bounty. Have you ever given a report and they're just like, yoink, and they never pay?
Are you saying like give a report? They say thanks to that. Yeah, nothing happens. Not in a case where they've said, hey, we're going to pay you something, or we want to give you something for your effort. Thankfully, again, I think they're more appreciative that you're reporting it, and they don't want to sour that sort of commitment from you.
Could be afraid that you're getting them, but you'll get them again.
Yeah, exactly. Yeah. Well, yeah. I mean, that's kind of what I'm saying.
You got them once, you can probably get them again.
So. Exactly. And they want you to report things to them, right? Yeah. It's creating that sort of positive reward in their mind, right? Positive reinforcement scenario. I'm coming to you to report in a responsible manner rather than blasting this into like Pastebin or ransoming it off on or selling it off on a black market site. Like trying to do legit things for you, do legit things for me, please. Any other questions?
Do you get repeat business? Do you have like, I guess,
yeah.
More so like they say, oh, can you do a full vulnerability assessment or a
yeah.
assessment on our whole structure?
Absolutely. That's something that has really driven growth in BAVSec. Companies, I always report under the BAVSec company heading, and it's worked out really well. For example, the Bitcoin company, exchange company, they gave me the bounty, 25 Bitcoin, which I thought was more than adequate, and then they emailed me back 1 or 2 weeks later, propositioning for, quote, to actively monitor their address space they provided going forward in case anything like this happened again, to prevent it from spreading. So it wasn't like a full testing contract, but to monitor their network with the project. So it wasn't bad. And there's been 3, 4, 5 companies over the last year that's happened with as well. Any other questions? Okay. Thank you.